Hello and welcome guys, and in this tutorial video we'll be looking at the HackTheBox machine called Frolic. So in order to save time on this quick tutorial video, I've already done the Nmap scan and we found the SSH running on port 22. We also got an HTTP Nginx service running on port 9999, which looks very interesting. We've got SMB on port 139 and 445. If you have a close look, we can actually see the NetBIOS name for this computer is Frolic, and we can also see the dates and time when this box was actually created. So the first thing I did on this box was to go straight away to the HTTPS or the HTTP service running Nginx. So 10.10.10. 111 on port 9999, and we get this welcome page. So straight away I threw this into derb to enumerate web directories or common web directories and files on this box. So while that is running, we can have a quick look at the port 1180, which we didn't get when we initially did the Nmap scan. So I went over here and it appears we've got Node-RED running on this box, but I wouldn't go further into this because this appears to be a red herring. So this is the interesting web application or the web server which we're focusing on in this tutorial. So enumeration shows we've got an admin directory. Open up the link, and we've got backup, open link, and we've also got dev. So we open our link as well. So the dev one says follow through forbidden. The backup one looks interesting, so we can have a look at password.txt. This password I am not human, so let's save that somewhere. So I'm just going to create a directory called nanocreds password, put that there, and what else? Found user txt. Says user is admin, and the other one is loop, which says forbidden. So let's go back to this admin, and it says crack me. So I tried in admin, password is password. Try to log in, says you have 2 attempts left. So right click, view page source, and we get some comments which points to a CSS file and a JS file. The interesting one was this JS file, so when I clicked on it, I could actually see the function for the login button, and I think it does a string compare the username to admin and password if it's equal to super duper looper password underscore laugh out loud, and then we get a login successful. So this appears to be hard coded into their web application. So we could try to log in, and when we login successful, and then we get these weird characters. So one way, you could just throw this into Google to see what it gives. So throw that into Google search, and Google able to say this is Ook programming language, which is an esoteric programming language. So we could try to crack this using an interpreter, translator of some sort. Click on execute, and we get this plain text saying nothing here, check this directory. So let's have a look at what this directory is about. So we go on here and put this directory there, click on paste, And here we're presented with something that looks like base64. So what I did here was to, I'm just going to say wget and get this whole directory. So paste that here, or I could just do a directory to say make directory content. So cd content, and I do a wget to get the content of this base64. So as we can see, save the file to index.html. So if I have a look, we go index.html, and if we take a look at this file, we should see the base64, and that's the content. So what I did in this case was to cut this file index.html, pipe that into base64 decode, and we can see now we got some weird characters. But a good interesting thing about this is if you look at the file header here, we can see it begins with pk, which indicates a zip file. So a bit of forensics here. So if we do search for file header signatures, it's a very good one by Gary Kessler, and if you take a look at it, we could search for pk file signatures, and you can see from here it says headers beginning with pk or the trailer file name 504b indicates a zip file. So it appears this weird characters we translated from base64 is actually a zip file. So what I did next was to say we can cut this index.base64 and then pipe that into xxd, and straight away we could see the hexadecimal character is 504b, which is the same as what we got here. So 504b0304, and you can see the first four, the hexadecimal characters here is consistent with a zip file. So this indicates this is a zip file. So what we could do is to cut the contents of this file, base64, decode it, and name it index.zip. So let's do a list, and we do file index.zip. We can see now it tells us this is a zip archive, which we could therefore extract. So I did unzip index.zip. It prompts me for a password. I don't know it. Say hello world. It says re-enter. Okay, so we have to actually crack this file because it's password protected. There are tools you could use. There's a tool called fcrackzip. fcrackzip, and it says you have to specify one or more files. So let's look at the help page. So we can say use a brute force algorithm, use a dictionary file, and we could have verbose. So let's see if we could actually crack this. So fcrackzip, specify brute force, specify dictionary file, and we're going to give it the share word lists, rocku.txt, and the file itself index.zip. So he's saying file not found. So it's been a while I've actually used fcrackzip. So let's have a look. So it says no file or directory found. User share word list rock.txt is. So let's have a look. Let's do a quick search on fcrackzip to see how to use this stuff. So cracking zip files will fcrackzip. We can see an example here. So -u, so -u is use on zip. Okay. So fcrackzip, and then we specify this. Okay, so this is an example. So this is the file we want to decrypt, and we can use this. So let's just copy this straight away. So we're going to specify this. So my brute force is still running. Okay. So fcrackzip that the dictionary file is rock.txt, and the zip file is index.zip. Great. So we can see now password found, and the password for this file is actually called password. So all we need to do now is to unzip index.zip and prompt for password, put in password, and we got the context of the file, the contents. So if we do a list, we do cat index.php, we can see the contents of the zip file. If you remember, when we did this, when we pipe this into XSD, you can actually see within the string here, we could actually see input index.php. So that was a file that was zipped into this zip file, into the zip folder. So all we have to do now is to, this appears to be hexadecimal characters, is to decode this. So I'm just going to look for X to ASCII converter. This looks good. Paste this here, and we try to convert. So we get something that looks like base 64 again. This time around, I'm going to look for base 64 decoder. Paste this here, and we decode. Okay, here we get another esoteric programming language, which appears to be brainfuck. And if we do Google, we could paste this into Google to see what the results is. Google search tells us it's brainfuck. So what we could do is to brain decoder. Okay, could paste that here, execute, and then we get something says IDK what is pass. So I don't know what is pass, and this appears to be some sort of credentials. So we copy that, we go one directory backwards and cd nano creds was it, and put in this as another password. Okay, so let's go back to our brute force page, and if you remember, we found some of these directories. So the next thing I did was to, normally Deb would do a kind of recursive enumeration on each of these folders. So eventually it found a directory within here. So if we go on to dev, and we do, so let's clear screen. So we do derb http, or just derb, put that in here, enumerate this. It eventually found another directory within dev, which was the directory called backup. So within dev, we have backup again, and there we can see this pointing to another directory called play SMS. So the enumeration eventually found backup, as you can see here, but to save time, that's why I'm doing this. So if we put in play SMS here, we get not found. However, when I put it straight after the port 9999, we get the play SMS web application. So after a lot of enumeration, I found out the play SMS is actually vulnerable. And if we do search exploit, play SMS, we see remote code execution, unrestricted file upload. So there are some exploits that we could probably do manually. What I did was to run MSF console and use the Metasploit module to actually exploit this application. So if you have a look at what Searchploit found, all of these exploits require some sort of authentication. So armed with the data we found, the credentials we found earlier on, so copy that, go back to this application, username is admin, paste the password, log in. We successfully logged into the web application. Remember, we also found credentials saying username is admin, so that's how I managed to get the username. So search, play SMS. Okay, so we've got two exploits here. One is and both of them were actually disclosed on the same date, both excellent. So I went for this one. So we could do use options. So we see password, and we say it's authentication required, and also requires us to set the username and password. So we'll do that first. Set password, and we provide the password. Set remote port to 9999, set host to 10.10.10.111, set hell host to our Kali machine, set the target URL or URI in this scenario as play SMS, and hopefully, fingers crossed, exploit, we should get a shell. So authentication successful, staging exploit, and we get an interpreter session. So I'm just waiting for this to drop us into a shell. It appears this interpreter session is hanged. Hopefully not. So it appears my Kali machine has frozen, so what I'll do is I'll just pause the video, and when this behaves itself, I'll continue. Okay, so we're back recording this video. So I restarted my Kali Linux machine and I'm going to try this exploit again. So we could use this exploit. Have a look at the options. So we set target URI for play SMS, and we set our host 10.10.10.111, set our port to be 9999, set cell host to be Tom0, which is our Kali Linux machine. Then we set the password to the password we recovered or were able to decode. So cd HackTheBox, cat creds. So this password for the play SMS. So have a look at the options, and all the parameters here have been set. So just gonna exploit. So authentication successful, interpreter session opened, and that should drop us into a interpreter shell. And there we go, we got our interpreter shell. So if we do get UID, we can see with www.data, so I'm just going to type in shell and we'll drop into a shell. If I do ID with www.data, and we can see if Python is installed, so which Python is installed, so python.c import pty.spawn, and we could do /bin bash, or get a shell, and then export term equals screen. So we're able to clear screen. If we clear screen now, we should be able to. All right, okay, so we're on the box. So we could try to figure out what users on this box. We can see two users as Sahey, another one as a user root. So we could go to cd home and have a look at these two directories. So cd use. If we do a list, we could see the user flag, and if we do a long list, we could see the user flag is owned by this user called use. However, the file is readable to all users, so it means we could be able to get the contents of this file. So we don't need to try to escalate to the user called use in order to be able to read the user flag. So the next thing I did on this box was to enumerate this box to see how we could elevate privilege escalation, or how we could conduct privilege escalation. So we could do ps orgs to see if there are any services running as roots. I doubt that, because we just use a www.data, so we might not be able to see if stuff like that is running as root. So what I did in this case was to run lean enum. So go onto my machine and locate lean enum.sh. So I've got it in my tools directory. So I'm just going to cd into this directory and start my Python HTTP server. Simple HTTP server. Port 80. Let's try to get my IP address real quick. So if config on 0. So that's my IP address. And I go on to the directory of AUSH, or maybe just go into the temp directory and do a wget http/leanenum.sh, pipe that into bash. Alright, so maybe we could just run bash on that straight away. leanenum.sh. Okay, so we enumerate in the box. So we can see sudo version, files running, processes as well. So I'm just going to give you some time to finish up. Okay, so that's all done. So location of content, bash history. So let's just go to the top, start from the top. So we can see is an Ubuntu 16.04, Xenil, hostnames Frolic, with current user www.data, we got user Sahe and root, probably logged in not too long ago. We're just looking at file permissions. So we can see this directory, permissions on these home directories. So we can see everyone can read these two directories by these users. So there's no cron jobs running, and we keep going. So after probing around, I think what I did on this box was to have a look at those users directories. So cd/home, we have a cd AUSH, and then I did cd AUSH or list, long list, cd into the .binary directory. And if we do a list, we see a file called ROP, which is executed by everyone, but also, strangely enough, belongs to user root. So this should have come up in our enumeration. Excuse me. In our enumeration, we should have found this, or if you enumerate to find SUID binaries, probably it would have come up. But this, so you can see this is an SUID binary, and the rope here gives us a hint that this is actually return-oriented programming, and that is what we're going to exploit to get privilege escalation. So if we execute this file, let's see what happens. So if we execute ROP, it prompts for a message. So we could say rope, give it some data, and we get a segmentation fault. So it appears this application is vulnerable to a buffer overflow. So what I did was to kill this cd HackTheBox. So do a list was to transfer this file over to my attacker's box, which is my Kali Linux machine. So this is the same application or binary, and you can see it prompts for a message. If I type in a few words, it just says message sent, but if you put in more characters, it just gets segmentation false. Right, so there are a couple of things we need to know is to find out if ASLR is enabled or is enabled on the Frolic machine, in order to see how we're going to exploit this SUID binary to get root. So we could say check ASLR enabled Linux. So let's have a look at this for the command. So in order to know is to use this command. So we could, so on my box, if we put this here, it says 2. So it means ASLR is enabled on my Kali Linux machine. However, if we attempt this here, you could see it's 0. So ASLR is actually turned off on this machine. So in order to exploit this, let's run LDD on the ROP binary. We can see this is the libc.so library which this binary actually uses. Right, so what we can do now is we could try to do a buffer overflow and then find the location of EIP, and once we're able to control the EIP, which is the extended instruction pointer, we would then be able to point the EIP to jump to a memory location and execute our shellcode. So that's what we're going to do. So the first thing we're going to do is we're going to use GDB. So if I do GDB ROP, and we could say run, and we give it the syntax, and you can see now we've actually overwritten EIP. So this 656565 has been written into EIP. Another thing we could do is let's quit that, and we could do this again. So we could say, and then we could probably, we could just give it this, and we could say Python -c, and we could print some number of A's. So let's say 200 A's. Okay, so same word not found. Let's do this run. Copy this. Paste that in here. Right, so we're able to override EIP, and we can see 414141 has been written into EIP, which is the hexadecimal character for, or hexadecimal characters for the hexadecimal representation, sorry, for the character A. So what I did in this instance was to use, so I'm just going to clear screen again. So locate pattern create. Okay, so pattern create, and we say pattern create generate unique characters for 200 unique non-repeating characters. Okay, so we get this, And then we could then run GDB on this again, run, and then just supply these characters there. And then now we get a segmentation fault. So what we have to do now is to find out these 4 binaries, the location or the offset where they actually overwrite EIP. So we copy this, go quit. So we locate pattern offset. That's where we have pattern offset. So we could say pattern offset, paste that here. Length is 200 and query this 4 bytes. So we wouldn't include the 0x, so we just put in from 62, paste that in here. Right, so the exact match of the offset is 52, so it means 52 bytes is what the buffer can contain, and the next 4 bytes is actually what overwrites EIP. So armed with this information, what we're going to do now is to create a Python script and use that to we're going to develop a Python exploit and then use that to exploit this binary. So I'm just going to open another window, cd HackTheBox, and make directory exploit, cd exploit. Now I'm going to call this nano exploit.py. Okay, going to come back here, clear screen. So the first thing we're going to do is to say from subprocess import call, and the next thing in import struct library. Now we're going to do some few magic in terms of locating certain memory addresses, which we're going to use to then exploit this binary. So create some variables. The first one is going to be libc. We're going to find the libc base address, so we call this libc base address. The next one is we're going to find a system address, the exit address, so the exit offset, and also the bin bash. So we're going to call this arguments offset, going to be the bin bash, make equal. So the first command we're going to run would be going to run LDD. So we're going to say LDD, specify the directory where I have my HackTheBox /ROP. I'm going to grep for the offset for the memory location for libc. So we get this. Because ASLR is turned on, if we try this again, we will always see that this continues to change. We do this again, we see it continues to change. However, if we do this on the Frolic machine, so let's say we do LDD, so we do LDD on the binary, ROP, grep, libc. So I hope you can all see that. So libc, we get this as the memory location for libc. If we run this again, paste that here, we can see the address again is the same. So you can see B7019. So that's indicating that ASLR, like we found out here, is not turned on. But on my own box, it is turned on, and that's why that continues to change. So what we're going to do here is to just pick one of these addresses. So I'm just going to go with the first one. Put that as my libc base address. The next thing we're going to do is to use the read elf -s, specify the libc so, and we're going to grep for system. Yep, I need to specify the full part. Okay, so here we have system. All right, so we have libc system. So we will take this address, come back here, put it into this, the exit function. So here we're going to grep for exit. So run the same command, and so this is exit, and we're going to grab the exit address, put that into our list. All right, what I'm going to do here is I'm supposed to put in 0x to specify this hexadecimal. So 0x, let's screen on here, and to get the bin bash we're going to use strings, and I'm going to say a-t-x, specify the I need to specify this. So let's go back on strings -a -t-x, I think that should be right, and we grep bin bash on bin sh. So bin sh, and we get this. So place that here, and you can see this is just 1 2 3 4 5 6. So we need to make this 8 bits, so 0 0, and then we have 0x in front of it. So it has to be 8 characters long. So here we are 1 2 3 4 5 6 7 8 with a 0x, and that's the same thing here. So we just added 2 zeros as padding for this. So the next thing is to define another set of arguments. So system underscore address equals struct dot pack I then we have a comma libc underscore base. So we using this, so I'm just to make this quicker, libc base address plus the system underscore offset Close that. The next thing is the exit address equals same thing as this. So again, the leave address plus the exit offset. And then we specify the argument underscore addr equals same. So this should be pack as well. This as well should be pack as well, and address plus the bin.sh offset. Okay, that looks good. Then we need to set our buffer. Remember the number of bytes that overwrote EIP, so A multiplied by 52. So buffer plus equals, so we just put in all of this in here as the buffer. So we're overwriting the buffer now with this the variables we created earlier on. So we have buffer equals exit address, and again we have buffer plus or equals, so this should be argument address plus the argument address. Right, so if you remember, so all we did here, we found the addresses of libc, the system offset, the exit offset, so when we run this exploit it would exit, and also the bin.sh, which would trigger the shell. So we have to indicate all of this into little endian and specify define new variables where each of this is then added to the addresses we found. We write that into an exploit buffer, and then we have to run this 501 times, because what we're trying to do here is to do an ASLR brute force attack. So the chances is this is going to try 512 times, and in one of those instances, if we are lucky, we should get a shell. And this is what is called the ASLR brute force attack. However, on the Frolic machine, if you remember, we check ASLR is not turned on, so we won't be doing this 512 times on the Frolic machine. But this is our proof of concept exploit, so we run it here first to see if it works. So I'm just going to run this, so 512 times, so I equals 0. So while, let's write a quick loop, while I is less than 512 and I plus equals 1 for the loop, print I, and we then make a call to the exploit. So we could say this is in /root /HackTheBox what is our exploit called, ROP, put a comma, and then we give it the buffer as the argument. Remember, when we run this exploit, it asks us for the argument or the message, and that's what we're going to be sending to the exploit. So this looks good. Fingers crossed. If we run this, should work. All right, and now we could say Python exploits.py, and there we go. After 86 counts, we have a shell ID, and we can see now is we are root. So this is the same exploit now we're going to run on our target machine, and hopefully it should work. So if I type in exit, it still continues to run. Eventually it's going to get out of the loop. So after 512, it exit the loop. So I'm going to clear screen. Go in here, we have the ROP. So I'm going to go into temp and create our exploit. So what I can do is to do kill the, so we could do Python -m simple HTTP server 8001. Then I could do a wget, get my IP address again, if config some 0, so I could do HTTP 8001 / exploits.py. So we've got the exploit. So if we do nano exploits.py, permission denied. Right, okay, that's it. Got it here. Right, what I'm going to do is, I'm going to develop this exploit on this box before moving it over here. So we can remove the exploit, exploit.py, clear it out. So I'm going to call this copy exploits.py to frolic.py. So I'm going to then edit this one, frolic.py. Okay, so here now we could do the same thing we did earlier on for this. So the first thing we're going to do is LDD /home /use /.binary and ROP, and we're going to grep for libc. So we got that address, so we come on here and put it here. The next thing we're going to do is use the read elf -s, and we're going to do / so we'll give it the libso library, grep for system, get the system offset, and that's the one we're looking for. So remember, we're putting 0x in front of it. Okay, Okay, that looks good. The next thing we're going to do is do the same thing here, but this time around we're grepping for the exit offset. So we're going to grep exit, and once again we got exit. What's this? So we go in here, 0x, put in the address, and finally we're going to do for bin sh. So we use strings -a -tx, and then we specify the library. So that will be lib /i36, was it? i386 -linux. Let's just get that. So if we did ldd /home /au /.binary /rp, was it? Grep libc. Okay, so this is what we're looking for. So now we do strings -a -tx, specify this, and then we grep /bin /sh. Okay, so that's the offset we're looking for. Go in here, 0x 0 that's padding, and then we put that here. So this stays the same, 52 is fine, but this time around we don't need to have this execute 52 times. So we're gonna get rid of this line, and also this line, and we just make the system call to the directory where we have the ROP binary. So that's home /au /.binary /ROP. That looks good. So now we could do a wget if config /0, get IP address, and then we do the Python HTTP server, HTTP on port 8001, and we get the Frolic .py. So we have our binary on the box. If we do a list, you can see a Frolic.py, and hopefully now if we run Python Frolic.py, we root. So we can see now ID, we root. We could do cd /root list, and that's the root flag. So wc-c root.txt, and we have the 33 characters. You can also get a proper shell, import pty.spawn, bin bash, import pty.spawn. It's been a long video, unusual, but we're getting there, or we're there already. Just to get a proper shell, that looks good. Yeah, and you can see we root. So there are a lot of resources online that explains more about ASLR brute force attack, which is what we just demonstrated. And I quite enjoyed this box based on the the CTF beginning, going through that for Play SMS to exploit, and most challenging was this ROP binary brute forcing ASLR attack. So I hope you guys enjoyed it, and I shall see you next time. Thank you.